here from Math Notations videos on YouTube. That's my channel, from Math Notations blog. And I've been posting a practice challenge SAT math problem on twitter.com/dmoraine for the past, I would say 2.5 months, 3 months. So there are probably 70 or more questions there. They don't all have answers or solutions. Today I'm going to actually demonstrate a couple of methods for doing a problem I posted a couple of days ago on Twitter involving 6 cards, 4 blue, 2 red. I use different shapes to make them distinguishable. And you're selecting 4 out of the 6 cards, and the question is, you're trying to find the probability of getting 2 blue cards and 2 red cards. There are 3 or 4 methods that are well known for these kinds of questions. The tried and true method of listing and counting is still perhaps the best for most students. Rarely on a standardized test do you see hundreds of possible outcomes which would make listing ineffective. Here's a case where you have fewer than 20 outcomes and the listing can be done in a couple of minutes. If you've practiced these kinds of counting and probability questions, then you'll find that you become more systematic in your listing. You don't have to use my organizational method here, but try to have a plan. In this particular case, I started by listing an outcome with no reds. In other words, all blue. I changed the color here to make it easier for myself. So 4 blues, no reds, and then 3 blues, 1 red. So that's my systematic approach, but you can do it any way you want. And if it's not so systematic, it's okay too, because there aren't that many to list. And then all the combinations that have 2 blues and 2 reds. Now, a couple of things we need to note here. One is, some of you will already realize that I missed 4 outcomes, which happens under pressure. I'll discuss that in a moment. Secondly, the reason we want to get you into the habit of listing 2 or 3 outcomes at the beginning is, even with advanced methods involving permutations, combinations, multiplication principle, laws of probability, you name it, having a list like this is vital. It helps you to understand the question just by listing 2 or 3. And then you can ask yourself the key question, does order count? In this particular approach, I'm not counting order. I'm thinking of this problem as you're being dealt 4 cards from a deck of 6. You're putting the cards in your hand. You want to end up with 2 blues and 2 reds, and you don't care what order they are in. It is possible to approach this question by considering order counting and using permutations, but we're not going to go there. All right, we're at the almost at the 4-minute mark, so I have to move on here now. At this point, again, you probably realized that I omitted 4 of the outcomes. I could have used the other red card with the group of 3 blues. So let's do a count here. We got one of these, and you can see my marker is dying. So I think I'll switch markers. All right, so we have 1 outcome with 4 blues. We have 8 outcomes, these 4 plus the 4 I left out, and then 6 more for a total of 15. And don't forget, when you're using the definition of probability, the ratio approach like this, favorable outcomes over total outcomes, you should think of this as 2 separate counting problems. The denominator is separate from the numerator. You have to get the total number of outcomes before you should be worrying about the desired outcomes. Now we have 6 favorable outcomes, so the answer is 6 over 15. If this were a grid-in question, you could actually grid 6 divided by 15. you don't have to reduce it. If you want to reduce it, you can. If you want to change it to a decimal, you can. Notice you don't have to fill these up with zeros. And you could start the 2 here instead of on the left end. So you have many options for gridding. If this is a multiple choice question, here's an important strategy. You've got a couple of minutes left. You're reading this question, you're not even sure what the question means. It's confusing, or you just think it'll take too much time. But before you skip it, trust your common sense, insight, and the experience from doing similar problems. And this is how I say it to myself. Is the probability 50%? In other words, is there a 50-50 chance of getting exactly 2 blues and 2 reds? My instinct, my gut, tells me no. Because there are more blues than reds, I don't think it should be 50-50. In fact, I think it should be less. If you come to that kind of conclusion, you look at the answer choices, eliminate all the choices that are 1/2 or more, change them to decimals if you need to, and you might have 2 or 3 answer choices left. Put down the first answer that looks good to you. Don't question it and move on. I'd rather see you do that than skip it. Now, in the remaining 4 minutes, less than 4 minutes, 3.5, let's discuss the other approach using a more advanced algebraic technique called combinations. The denominator, the total number, can be denoted that way, 6C4. There are many other math notations, get it? Math notations. For writing combinations, C stands for combinations. So you're saying this notation means the number of combinations of 6 objects choosing 4. From 6, select 4. Now, there are various ways to compute this. One is by definition using factorials. You'll learn this in algebra. We can work that out and get 6 times 5 over 2 times 1. I'm skipping steps here because I have a little more than 2 minutes left. That, what happened to the 4, 3, 2, 1? Well, that would be canceled by the 4, 3, 2, 1 from here. And, of course, we get 15. The other method is to use your scientific or graphing calculator. Make sure you're comfortable with where the combinations key is and how to use it. If I have time on this video, I'll show it. I don't think I will. So let me move on. The numerator is a little more complicated. Now you want to use combinations to count how many outcomes we'll have 2 blues and 2 reds. Well, you've got 4 blues to choose from, and you want 2 of them. And then you've got 2 reds to choose from, and you want 2 of them. And since you want 2 blues and 2 reds, you could then, the order doesn't count. So you're not concerned about in what order the cards are selected. You just want to end up with 2 blues and 2 reds. This is called a conjunction. I don't want to get into all the principles of counting and probability with dependent, independent, conditional, mutually exclusive, and when to add, multiply, and all that. Just copy this, practice it. You want 2 blues and 2 reds, you multiply them. This is 6, this is 1, so again we arrive at 6 over 15, or 2/5. This is for the more advanced student who has done this many times and is comfortable. Well, actually, with a half a minute left, I could turn on the graphing calculator here. I have no idea how much of this you can see. I'm going to put 6 in, press the math key, right cursor over to probability, or left cursor, go down to NCR, enter, put in 4, press enter, and there you see 15. And that's a way of computing combinations quickly without factorials and so on. So you can practice this. I'm going to continue with part 2 of